You're listening to the Reinvest Podcast, where each Tuesday we show business owners and entrepreneurs how to reclaim, reconnect, and refocus their life by bringing you the top real estate professionals in the industry. We'll help you diversify into real estate by equipping you with the tools and tactics to build generational wealth. Your hosts, Garrett Gatton and Seth Simonillo. Hey guys, welcome to another episode of the Reinvest Podcast. As you can see, we are not in our typical studio.
It's a better studio. It's a better looking studio than what we have.
We're in the process of negotiating this to be our permanent studio. We'll see how that goes.
And my permanent home.
Yeah. For those of you who are watching this on YouTube, we are in the first 3D concrete printed home in Ohio. And joined with us today is John Smoll with Sustainable Concrete Innovations. Did I say all of that correctly?
Yeah, you did. Great job.
Nice.
There's some specific vernacular involved there, but this is pretty exciting for us for a lot of reasons. First of all, the nature of what we're in right now, I think, represents a big shift in the way that construction might be done in the future. Concrete homes have been around for a long time. 3D concrete printing has been on the scene for a little while. But you guys were able to do this in Ohio for the first time, and this is the finished product. So we're really excited, and thanks for hosting us here. So
yeah, thanks for coming out. We can show you. We're really excited about this. The technology, for one, I've been a builder for over 30 years, both in Michigan and then here in Lima for the last 11 years. And you know, this opportunity kind of came around in a roundabout way. I've been watching 3D printing for, I don't know, maybe 8 years or more, maybe close to 10 that I've...
And how long has it been around?
Like, I would say in active, you know, there've been some people working on it for maybe 15 years, but okay, like really about the past 10 years is probably when we've seen the most
when most people think about 3D printer, they think of like something that can, you know, they can mess around with and create like a replica or a cast die set or something like that.
Yeah, I used to have a 3D printer, like that printed ABS.
Oh, right.
Yeah, and you know, that was fun.
This is a little bit of a bigger scale.
Yeah, really, but it's the same technology, right? The same computer code that's doing a micro project, and I wasn't one of those people. So I grew up a little bit before you guys did, right? So, you know, at the beginning of computer technology, really wasn't into computers. You know, growing up, I was a farm kid, grew up on a farm, and got into doing construction work and using my hands. And when you're 18 years old, all those things are great, right? So now, a couple of years later, and knocking on the door of 50, you know, we're looking for another answer, really, and not seeing it, like you're just not seeing it around. And I had seen this 3D printing, you know, like 3D printing. I'm like, oh, that's really cool. You know, some tiny home communities, some stuff. I'm like, yeah, it's pretty cool. And in my mind, I'm going, this is something that, you know, my kids might see, right? Down the road, this is something that, you know, might, and I'm thinking the same thing that almost everybody does. Well, it's concrete. Like, how do you work with it, right? And one of our partners, my partners in the Sustainable Concrete Innovations, Anthony McMichael, this was his dream, really. Wow. He saw something and on 3D printing, did some you know, looking into it, and went to Nathan Metz, our other partner, and said, hey, you know, I'm just kind of thinking about this. Maybe going to try to get a printer. Might try to print a house. You know, what do you think about it?
Just casually one day.
Yeah, just kind of talking, right?
Just thinking about getting a concrete printer.
Yeah, just thinking about getting somebody in, and Anthony's great with that. He's great visionary, you know, and dreamer, right? So, and Nathan said, hey, you know what? He goes, I think that's a great idea. Like, you know, as they talked about it, and he goes, I you know, a friend of mine. So Nathan is a friend of mine. Started out as a customer years ago.
Nice.
Built his house for he and Melissa, and had worked for his family and Melissa's family, and did some building for them. And so we just kind of got a relationship going that way. And Nathan called me one day and he said, hey, John, he goes, you know, have you ever heard of 3D printing a house? I'm like, yeah, actually I've heard about it, you know. And he goes, well, you know, I've got my wife's cousin, you know, we're talking, and, you know, we think you'd like to do that in Ohio. And I was like, no, you guys are crazy. Like seriously, like, I'm like, have you thought about this, Nathan? You know, like, do you know, like, we have freeze and thaw, like everything in concrete that I see concrete printing, like I see this happening in Florida. I see this happening in Texas,
stable environment,
Arizona, right? Like, do you know what concrete does? Like, look at a driveway that's been around for a while, right? Like, what happens with freeze
You had an
thaw?
intervention with him. Yeah.
Yeah. So, and he's like, look, will you at least go to Texas? Like, we're thinking about going to Texas, like seeing one of these in process. Like, would you go with us? And he goes, I trust you, but let's go look at it. So that's really was the beginning for us. Wow. That was about 2 years ago, actually.
And which group was that in Texas that you went and saw?
So that was Hive 3D.
Okay.
They were printing their first house at the time. Okay. Andre Radenko, who we ended up getting to come print this house with us, was there. And originally they thought, this house was going to take, a month or two, and I think they were there for like 7 months printing this house, so that's one of the natures of concrete, right? So concrete, they're in an arid, dry, lots of heat, lots of wind, and so concrete, you try to take concrete in thin layers like that, and you deal with shrinkage. There's a lot of things that they were learning as they were in the process of this. And so, I'm there, and I'm like, wow, it's really cool. I do like that, but I just, guys, this isn't going to work in Ohio. And so they came back to me, the following spring, and they're like, John, we really want to do this.
And the weather was the biggest variable for you to be suspicious that it could take here.
Yeah. And when I see them struggling to build a house in 7 months, right? Like, so we've seen the articles, we've seen it's fast, it's all this thing. And then you see them, and they're working through the process, right? And doing a great job. Like, I'm not, they were doing a good job. They were working with it. They were learning things. And so I just said, man, I guys, really, do you think this is the best place? And they're like, yeah, but we need you. They're like, you need to be on board with this. You need to be our GC. We need somebody in the building community who'll embrace this. And I said, okay, fine. Like, I'll put the slab in. I'll do your site work. I'll get it ready. We'll come in with our subs. We'll finish it out when we get done. And one of the things when we started looking at it was, what does it cost? Right?
Right.
So get me a price for a 3D printed house in the center of Ohio, right?
Right. Easy. I'll just look at the comps and the materials.
Right. Yeah, not too many bids are gonna, be produced for that.
Yeah, and so that was the thing, and really, kudos to Nathan and Anthony both. They're like, you know what? We don't know what this is going to cost, but let's do it.
Wow.
And so, we really just dove in, and so we got the site ready. There was a little bit of delay getting the printer here and getting started on it. And, our expectation from the get-go was like, okay, we're printing a house. What does that mean?
So when did your interest level transition from, I'm going to get the site work ready, and then you guys do your thing, to I'm an active participant in this?
Yeah. So what happened is I was still a skeptic, right? And I worked through the design process. So I actually did the design for the home, the floor plan, worked with Andre on, had a couple of guys that were here different times. We were talking about how are we going to build it? And so how do you design a 3D printed home, right? No clue.
Yeah.
So Andre's like, well, we're going to, walls are this thick, walls are like, how do you do this? So we just kind of worked through a couple of meetings. They were here a couple of times and looked at it. And with my design guy, we came up with the design, we came up with the wall thickness that they had specified. And then Andre shows up with his printer, and it's like, hey guys, you need to provide me 2 guys on site full time. We need the materials here. And so, like, initially we're thinking this group that was going to come help us print
is a turnkey solution.
Yeah, like they're going to handle this stuff, and it's and so fortunately, I'll say this: fortunately, it wasn't. Like, this was really what got me on board, right?
Interesting. So you got thrust into it because of a miscommunication about what he needed to accomplish this.
Yeah,
and you volunteered to be here.
So there was a third party involved as well, that kind of an intermediary between, and I think that's where maybe some of the translation. We weren't working originally directly with Andre, and so when that happens,
it's a game of telephone.
Yeah, telephone, really. And so that's what happened. And so Nathan just called me and said, John, we got to figure this out. Like, what do we need to do? And I said, you know what? I've got a guy that can handle the on-site stuff. I'll put him there. I'll make that commitment. And then we had some mechanical issues with the pump, actually, that pumps between the mixer and the printer head, and had some issues that way. And so we had to start doing discovery, like, okay, where do we find this stuff? He was having a little bit of trouble sourcing.
Like parts.
Yeah, parts, right? So
for a 3D printer.
Yeah, and it's funny how some of this stuff works, right? So I have a friend from the UK who was visiting during that time, and so we're here, and he's like, yeah, let's look at it and see. And so the stater, he's like, yeah, let's do some looking. And so lo and behold, there's a supplier in England. Like, so he phones them, So, like, it just, the stars were aligned, right? Wow. And so once I started seeing the printer in action, like what it was capable of doing, and we had our own set of learning curve, right? Like a lot of learning. So when you're doing it, and actually,
well, even Andre, right? Because he was used to a very different climate that they're printing in, and now you're in Ohio. Now, is it fair to say when you were printing would have been comparable to the conditions that he was used to in Texas and Arizona?
not in Texas and Arizona, but Andre did a castle project actually in Minnesota quite a few years ago. Yeah, so he was so Andre's a pioneer in the 3D printing. He's probably has more print hours than any one person alive. Like he really has printed a lot.
He is
right?
the guy right now.
Yeah, well, I mean, he just has a lot of experience. Like he's a wealth of information, and I think a lot of what would be his competitors, in the market have used a lot of ideas, used a lot of the things that he has learned. Incredibly smart guy, and we were fortunate to have him here. And but through the process, like everywhere you go, so that's one of the challenges. So the sand is different. Is it a crushed product? Is it a natural product? Is it angular? Is it rounded, right? So all these things make a difference, and that was really one of the problems that we ran into, is that our sand, while a great fit for 3D printing, was more angular, and so it was tearing up the stators, right? So what typically would last like maybe for one whole house.
You're talking like looking at a piece of sand under a microscope, that it's not rounded, it's angular.
Yeah, you can actually see it with your naked eye, and you can feel it. You can feel it like so. Somebody who's experienced in construction would feel that. Not something that we had ever thought about.
Right.
It produced a great product, but we had some issues, with that particular design that he had came up with for the print. So going through that process, and really as things, and then I became the guy that I was the go-to guy for like, okay, we got to get this done right. So. We need this, we need that, John, how does this happen? And I love a challenge. So like, I'll just, put that up front. Like once it became like my baby, like, get this done.
Once you committed.
Yeah. Right. And I'm like, okay, so like how are we going to make this work? And really that's, I think in a nutshell, what happened is that we pushed through. A lot of people pulled together to get it done. And, once really we realized that we were responsible for our destiny, right, on this. Like we needed to lock into this and see what was going to happen.
At some point, there was only one way, and it was forward.
Yeah. Yeah, so you can either tear it down and decide to just give up, right, and move away from it, and that doesn't fit my nature very well. So, yeah, I like to see a project through. And so that was kind of the beginning. Anthony, great ideas. Nathan kind of put the group together. And then so we got the walls done, and we had lunch, and they said, okay, so what are we going to do? Are you going to be on board? I said, guys, this is phenomenal. Like I absolutely, was a hard skeptic, and like I'm pegged like the other way. Like this really, like I see it now. Like I see and I see that it's possible.
So talk about from a construction perspective, you've got 30 years of traditional construction experience in terms of, stick frame, stick build, custom homes, remodel. How does the construction process differ from a stick-built home to the 3D concrete in terms of order? Like you do your site work. Well, do you put your slab down, and do you put your walls up off the slab? I mean, like how does that translate? Yeah,
so getting started, it's much like building on a slab. So you're putting down your foundation, you're putting your slab, keeping in mind that 3D printing is a lot more weight. Right. Mm-hmm. So the amount of concrete that we're placing. So the site work has to be done. I don't know what the ratio is, but it's considerably more. Like we had, I think just cement, right? So cement is the powder that you mix with sand and water and other aggregates and additives, plasticizers. The cement is the catalyst that when you add water to that, it then eventually goes through a chemical process and becomes hard, right? Mm-hmm. So cement, I think we had in the total project, including the wall fill, something like around 27,000 pounds.
That's before you
add
add water.
That is a significant amount of cement.
So, and now some of that's on the exterior, right? So I think we had several dump truck loads. I don't know what our total weight ended up being, but number of dump truck loads of sand.
Wow.
And, tons of cement, tons of, the plasticizer we put in it, and there was a plasticizer that went in it, additives for speeding up the process, air entrainment, things like that people in the concrete industry
that
would
custom
know.
Mixture that you guys have is on Wikipedia?
Yeah, absolutely. Yeah, we published this. So concrete is really interesting. Concrete houses have been around, for millennia.
Yeah.
Yeah, the Romans.
It predates.
Romans they built with concrete years ago. And in fact, they had a superior concrete that is super amazing. It's something I've been watching. We do a lot of concrete construction, flat work, that type of stuff. And I love what's going on in the industry. And so I kind of watched this technology, and the Romans had a self-healing concrete. Like, that's our problem. Like, so driveways deteriorate, you tear it out and you put it back. Yeah. So that's why, like, Roman structures are still there today. They're actually self-healing. So you get a crack in the concrete, and that spells doom for most concrete eventually, because what happens is water infiltrates, and through whether it's water movement or whether that's freezing and thawing, over time it erodes, and then you get movement, and then
like the Hoover Dam. We're going to make this so thick that it's going to take hundreds of years for this to even crumble. And
we expect that someday it'll be crumbled, right? Like someday it's going to happen. So, but the Romans had a process of doing it where it was self-healing. And so they've recently discovered, they've been, of course, studying this for years.
Isn't
they're
it funny? We think we're so evolved. We're just like, man, we have all this modern stuff, and this is thousands of years ago. Yeah.
So without getting into the secrets of concrete, like, they think they figured that out potentially now. Like, there's, and so with a property of something that was in there that they'd overlooked for years, just thought it was a, accidental filler, right, in the concrete, that actually this was causing a secondary hydration process, so that this chemical was being mixed in there, caused a secondary hydration, and it was actually going back and rehydrating, and as it would leach through the joint, through the crack, it was actually rehydrating and sealing that crack back up again. So pretty awesome. So these things are interesting to me, right? So they're very interesting to learn and to know, and not being a scientist and not understanding how all these things work, but really the end product and how this works is that you need to have a good quality concrete mix with a small aggregate that can be pumped, so that today's computers can place it where it needs to be. It can get hard in the amount of time that it needs to be there, which is another whole source of consternation and complexity for a builder. Like, you need a concrete that's going to dry not too quickly, and if it dries too quickly, you get separation between the layers. If it dries too slowly, then you end up adding the weight layer upon layer, and then you get layer collapse down lower.
You have any idea how many layers this is?
I haven't counted it. No, I don't.
It's more than 10. I'm just looking at it.
I'm just.
So it's 9 feet tall, and they're roughly 3/4 inch layers. So So what's that? 100 and something.
Yeah, I wasn't going to take a stab at it, but I trust you. So you put, it's much like a slab. Talk about the wall structure itself. Like, some people might think this is 18 inches thick of just straight concrete. Like, what is the actual is there a cavity?
Yeah, there is a cavity in it. So we're printing, when you think about 3D printing, we're actually printing forms. So the print is about 1.5 inches wide. Each as it's laying down, it lays about 1.5 inches of concrete.
Like from an aerial view looking down.
Yes, sir. Yeah. And so on this particular one, we did an interior and an exterior cell. All the interior walls are the same way. So you have an outside and you have an inside. Concrete cracks, right? One of the things you get guaranteed by every concrete guy. Like, they guarantee it's going to get hard and it's going to crack.
Right.
So as you look around the house, you'll notice, like, at the window areas, we have expansion joints that run down below the windows. Some of them are concealed. They've got a caulk in them now, right? They've got a sealant to keep, but we print those in to allow it to crack in an area that we want it to crack.
It's controlled.
Yeah, it's controlled. And so then we came back, in here we came back and filled the exterior wall cavity with a lightweight concrete, or a foam crete. It's called different things, but essentially think of shaving cream, right? So we bought a foam generator that makes shaving cream by the barrelfuls.
Wow.
Yeah, so with a liquid water and then a liquid a foaming agent, we make a foam that's a long-lasting foam. So if you just pumped it out in the yard, it would be there for a couple of days. And before it would eventually, and then we mix cement slurry. So think that cement powder we talked about again. So we make a slurry out of that with water. We mix that with the foam, and then we pour that in the wall.
Now, was all of this standard from Andre's previous experience, or was some of this evolving through you guys doing this for the first time?
So I think the fill is pretty standard in like, lightweight concrete has been around for a long time, also used for a number of different fill applications. They use it in bridge abutments, mine shafts that need filled, those type of things, because it's lightweight, doesn't have a lot of aggregate. It's easy to make, right? And then once it's hard, it's denser than a typical like a foamy product would be. You know, it has some structure to it, but really what happens is the foam eventually evaporates out of there, and then the cells that are created by that that have been around the outside of the foam bubble is cement, and so it creates like a crystalline structure that would hold up. So
does that gives provide structure or R value?
R value, yeah. Okay. So it does provide density. But if you think about standard concrete, like the concrete that we're sitting on the floors or foundations, that type of thing, the walls were, for a cubic foot, you're 180 probably to 220-ish pounds per cubic feet.
Wow.
So a block, you know, a foot square would be difficult for one man to pick up, right? So lightweight concrete that we put in is around 30 pounds per cubic feet. Okay. So much, much lighter, right?
Right.
So that gives us R value. And so the R value that you want from your exterior wall, you make your wall thickness, your cavity size appropriate. Right. So then for the structural part of it, we actually have columns.
Like if you're ceiling, you're putting R30 in your ceiling. What's the R value of the exterior wall?
So right now, code calls for R21 in your exterior walls, right? So we have really close to an R30 exterior wall assembly here.
Wall. Wow.
Yeah, so very efficient exterior wall in this one. And I think code actually calls for R48 in your attic now. So
wow.
Your wall assembly, we have around an R30, maybe just a little bit under that. But also within the wall, we poured concrete columns, so smaller diameter, like 8-inch round columns poured within the wall. Those are standard concrete. And then around the top perimeter of the house, there's also a concrete bond beam, we call it. So within the wall is a concrete beam structure with rebar, with standard concrete in that. That's poured through the walls, through a pier system down to the foundation, rebar reinforced all the way. So that gives us two things. It gives us compressive strength, right, from the roof sitting on top, and it also gives us tensile strength from the roof if it were trying to blow away, right? We've all seen the tornadoes. We've all seen those things. So that gives us something. So we're actually anchoring the roof system not just to some lightweight concrete in a wall, not just to a printed wall structure, but actually all the way down to the ground. Yeah. So that's kind of the technical way of building this.
Somebody looking at concrete walls, maybe not familiar, a big question is rough-in, right? HVAC, electrical, plumbing.
Yeah, that would be interesting.
How does that apply to this?
Yeah, and interesting, the number one question that almost everybody asks us that walks in the door is, how do you hang a picture? Yeah. Like, we've probably heard that like hundreds of times already. Like, how do you hang a picture?
You ever heard of a command strip?
Yeah, so, well, actually, we just, with a hammer drill, you can, and you know, the cheapest hammer drill at Home Depot or Lowe's or Menards will drill you a little hole. You put a Tapcon in it. It's pretty, or an anchor.
Hope you want that picture there.
So it's actually pretty repairable. Yeah, we found out through the process of printing.
What do you repair it with?
So you can repair it with a caulk or with even a mortar. You can just smear some mortar into it. So yeah, it's not difficult at all.
And the walls are already rough. So I mean, if you guys aren't watching this on YouTube, go to YouTube. But the walls are already rough. So I guess it probably isn't that noticeable by the time that you fill it back in.
For sure. There's a lot of
especially on the painted walls. Some of these walls we've left raw. You don't have to paint them.
Well, and somebody could put drywall on the interior if they wanted to.
Yeah, you could. And, you know, we get that question too a lot. You know, could you put drywall on the inside? It's like, yeah, you can, but you wouldn't. Like, because you'd probably plaster these. Like, if you were going, you could plaster or render right over top of these with a cementous product. You wouldn't actually need to hang drywall.
Wow.
Yeah, and that gets into the affordability and really what makes the heart of a 3D home tick, right? Like, why do you choose 3D? Like, there's a number of different thoughts behind that. One of them being, I really like it. It's very aesthetically pleasing. It's durable. We live in Tornado Alley. How safe can this be? And there's lots of different graded answers for that based on what we want to do as a builder, right? As a designer. So as we design these, we have the opportunity to do a lot of those different things. But really I think the bottom line, if you look at it from an affordability standpoint, is that if you say, for example, just printed the exterior wall, like there's companies out there who are just printing exterior walls. They come inside, they either use steel stud framing or conventional framing. They finish them out with drywall or wood or something else along that nature. You're still bringing those trades back in. And so for me, the real seller on this, was when I saw that I now can take high school students coming out of trade schools that have got skills with a laptop, right? They grew up working on an iPad. Their schoolwork, like they know, they probably have been in 3D printing classes going through school. They've been exposed to it, right? So now I can take the technology that we're using to build these homes, and I can take a young person and set them down that's interested in it. Like building a house with a tool pouch and nails and a hammer, like what are those? Which end of the hammer do I hang on to? I mean, serious, like,
it's ironic that somebody would be more familiar with a 3D printer than they would like in a modern,
in like a hammer
traditional
or
application
something.
of a construction.
Yeah.
Well, and I don't know if this is what you're hinting at. Construction trades right now are in a deficit of people stepping in and filling those voids. So finding subcontractors and just quality, reputable contractors is difficult.
Yeah, and we're paying fantastic wages for somebody coming out of high school without, for
any
somebody
experience.
that has a desire to learn. But that goes back to, I'm taking somebody out of a trade school that has an interest in building. And I'm taking 3 to 5 years and investing in them to get them to a place where they're semi-autonomous. Like they can go out, they can take a couple of guys and they can go start doing things on their own. Mm-hmm. But now I can take with this technology somebody who's interested, and I can put them in front of a training program. We can go out and do some test prints, and within a couple of weeks, they're very successful doing. To me, it's a game changer to me because first of all, it's interesting, right? Second of all, there's a purpose behind it. We see the need for a housing. If Ohio truly is 300 or 270,000 housing units short. Like, how are you going to get there with trades that are in decline?
Yep.
And so back to your question on trades, HVAC and those type of things, all of those are encased within the wall, right? The electrical's in the wall, the plumbing's in the wall. So without getting into a lot of boring details, those are put in kind of as we're going. So as we're printing, we're adding the boxes in, we're adding the conduit in, and then pulling the wiring later, that type of thing.
So it's conduit back in there, and you pull wire after the fact?
Yeah.
Okay.
Yeah, there's other ways of doing it. You can slice the bread as thin or as thick as you want, but really you have to get those utilities in the wall.
So what would you say are the major pros and cons for a 3D concrete printed home?
Yeah, I think like the biggest pro that I think everybody sees right away is time. So if I can come in for a typical builder, like I'm going to say, for a typical builder that's got a crew that's been building homes for years, right? He's got a crew of 3 or 4 guys. He's got a drywaller. He's got a painter. He's got a siding guy and a roofer. They're going to come in, and we're going to come in and come alongside of them as a partner and show them how that they can take that same crew that they were building one home with, and they can build 3 homes in the same time period. That is going to open the eyes of a lot of people because it's going to take a little bit of training for them to learn how to work with the concrete. How do you put windows and doors in? Just slightly different. But for an experienced carpenter, it's not difficult. It's different. That was my experience. Like none of this was difficult. Much of this was different, right? So from a different angle, and how do you plan for things?
You had the tools and the understanding of construction to know how to do it. You just hadn't done it that way.
Yeah, a lot of it is just process, right? Like the way you do things. And so learning that you can do, that's really the biggest pro for this is that now, from a pro standpoint, we come in and set up a printer on top of a slab that's there. Now we're at the same point that a builder would be on day one, right? So on day one, now they're going to start their framing, then they've got to get their siding crews, they've got to get everybody in. So then eventually drywallers to hang the drywall, to finish the drywall on the inside. And really for us, it's a matter of, say, a typical 1,200 square foot, 2-bedroom home, something that's small, maybe a 1,500 square foot home. That's 3-bedroom. We're looking at probably 5 to 7 days if we're working 4-hour day or 8-hour days.
Wow.
Like we're 5 to 7 days. The walls are going to be completed. So now you don't need your siding guy, right? So you can put him on something that's, oftentimes roofing and siding guys are doing the same thing. So now that siding guy can be putting windows in and then he's finished, right? There's some exterior trim work that needs done. You're going to have porch ceilings that need to be done. Those type of things. The roof needs to be put on by a framer, but then you're not bringing in a drywaller. Your trades are instantly coming back in and doing their work, and then we do the insulation work after that. They do the entire trade work. We do the insulation, and we're actually we're in the middle of actually working on. I don't think we're going to be using the foam concrete in the future because there's much more efficient ways to insulate with closed cell foam that allow us a much higher. Our next house is going to have an R50 sidewall.
Wow.
Yeah,
That's
like
so
you're talking
wild.
like freezer, right? Like restaurant freezer type. So
Well,
you
that's
talk efficiency.
Pro is
crazy.
the energy efficiency.
The
nature
energy
of this.
efficiency, yeah. So speed, energy efficiency, a force multiplier for your crews that you already have, the trades that you already have. And I'll be the first to admit that it takes a little talking to get a contractor or a carpenter, especially that works for the contractor, right, to come in. It did for me. You know, someone who's always interested in new things, who loves to learn things. It took a little bit of a process for me to come on board.
These are guys that obviously they make money by being efficient, right? So maybe there's some skepticism of like, how long will that take, you know, to learn something new? We're all creatures of habit. So there's a lot of variables to get somebody to overcome those and get them on board with doing this.
Yeah, absolutely. So on the pro side, I think those are some good pros. You know, when you think about finishing the interior, even like you look around, there's no base trim.
Yeah,
We don't base trim it, right?
Right. There's no flooring.
So,
It's just I mean,
yeah.
it's stained concrete flooring.
So we polished these a little bit. We did a light grind on these, stained them.
Which they look really good.
This is a heated floor, so we have heat, have concrete, you know, heat in the concrete. Again, like, is this necessary in every home? I don't think so. You know, we did it here. Heated floors are nice. We also did high efficient heat pumps, so air sourced heat pumps. So our air conditioning and our AC, our initial heating source, like on temperate days in the fall when maybe it's 50 degrees and you want a little heat, you're not going to turn the floor heat on because you know, in 2 days it's going to be 80 again, right? And that thermal mass is going to cook you out of your house. So we did, and we could entirely do these with air sourced heat pumps. Like, excited about that too, because efficiency, when you talk about super efficient structures, super efficient HVAC systems, now you're talking again for the end user, a lower input cost to keep that.
All of that's huge, especially when you talk about some of the energy crisis stuff that we've been in, right? I mean, everybody's been looking at their electric bill, gas bill. Energy has been rising in terms of cost. And so to have an ongoing system that's going to really reduce some of those expenses, that adds up big.
Yeah.
I would be interested for you guys, after you get some historical utility bills, or how often do you fill the propane tank, to be able to kind of dollar cost average that compared to a traditional stick-built structure.
Yeah, we certainly will be able to, and we should be able to this coming winter, and we're going to have a couple examples. So this one is you know, one type of exterior wall, one type of print, right? Our next project is going to be a little bit thinner exterior walls, but with a higher R value. So we're going to have some real experience, and actually the next one we're just doing air source heat pump in the next one. It's going to have some electric heat strips, primarily because that's one of the things that we're really looking to get into, you know, more and more, and is to prove the concept of what affordable housing and how that works. So,
and let's segue into that as an application, right? Because up to this point, you've alluded to the fact that in some of these other places, these are trendy custom homes, people with lots of money that have been paying for 3D printed homes to kind of have the exclusivity factor of like, I have one of these, right? And you guys see a different application for these.
Yeah, and I think you know, the 3D printing industry in a whole is looking for how do we apply this to construction, right? So once you get a printer, once you get a mix that works for your concrete, like for your ink, right? Once you get all those things, then how does that apply in a real world in an area like Central Ohio where this has never been done before, right? How do you make that work?
Right.
So and there's been there's a huge interest in it. It is absolutely unique, and you can do some really incredible things with 3D printing, because now what used to be square and angles, right? Curves, rounds, geometric designs are perfectly possible as long as the guy running the CAD program can design them and you stay within the physical angles that we can print in, right? So collapse, right? You have to print something that isn't going to fall down before it gets hard.
Right.
So as long as we're within those parameters, we can do a lot of really neat things.
Yeah, even looking around, like, things are rounded. It's not square angles all over the place. That hallway, it just looks rounded, and that's pretty cool.
And you're probably always going to have to do headers above a window, right? Because again, that's that collapse principle.
Yeah. So these headers look like wood. They're actually wood support for the concrete. So that's a concrete header actually, poured within. So we build a wood structure, pour the concrete within it, which gets hard and then becomes tied into the rest of the structure.
So you just needed one layer to be able to lay off of.
Yeah, so we actually built like a trough. Like think about a trough, and then we apply our trim finish over top of that. But that's not necessary. So with 3D printing, we could either build a temporary wood structure and print over that. So we could print right across the top of it.
Like a form, yeah.
Yeah, so we just put a form there that we can print over to build the top of that, and then we pour that with concrete, and then it becomes a beam, right? A bond beam. And or we can print all these on the floor, put a piece of plastic down, print the headers the right size on the floor, fill them with concrete, and then just lift them with a lifting device like a telehandler or a crane and set them in place.
Wow.
So there's multiple ways to do that. We really like the look and feel of mixing the wood and the concrete kind of thing, and so that was part of our design here. And eventually, we're probably gonna explore different avenues of
Who's
doing
your trim
that.
carpenter?
So my son, so I have both of my sons work with me in the business, and my oldest son Aaron is a great carpenter and does a great job. Yeah, we've got a couple guys that work for us that do a good job.
That's awesome. So from an applicational perspective, we've talked about really what your interest is. How does this solve the problem of affordable housing? Yeah,
so time and cost of materials, right? Labor is a huge driver of construction costs today. Greater than 50% of construction costs are labor. When you look at the whole package, right? Plumbers, electricians.
And when you say time, just to be clear there, that's actually two variables packaged into one. Yeah. The longer you're on a job site, the more cost there is involved. And then it's opportunity cost because you're tying up resources when you could be deploying them on a future build.
Yeah, absolutely. Yeah, so time is money, right? So because we're paying labor based on an hourly rate, more than likely to most of these guys are doing the work. So time is money. So when we reduce the amount of time that's involved, and we reduce that in a number of ways, automation, of course, is a big driver of that, but also the number of finishes that we need. We've reduced the number of finishes, and we haven't even talked about really one of the big pros on this is waste. Like think a typical construction site, how many dumpsters are sitting outside? How many times do we fill that with waste? With 3D printing, I say, at the end of the job, your waste is in a few pails. Your waste is in a small pile of initial ink from when you first start the print. You have some
dial it in.
Yeah, dialing it in, getting it going. But the reality is that if you take that waste when it's still wet and you pour it out in the driveway, it's just driveway material. Like it isn't even waste.
Wow. So
properly managed, like the amount of waste is exponentially reduced.
Wow.
So yeah, that's another big factor in this. Think about vinyl siding, right? The amount of vinyl siding, fiber cement, regardless of what that is, drywall. Yeah. Like almost every house we fill a dumpster with drywall. That goes to the landfill. Not happening in these houses. So that's another whole level of sustainability that I loved about 3D printing, right? Another pro.
So, and this isn't necessarily what we plan on talking about, but my mind has just been kind of working as we've been talking through this. Set aside the 3D printing, there's been a lot of leaps and bounds in terms of concrete innovation, concrete staining. Concrete businesses are blowing up right now because of the demand. They can't keep up with it. Have there been developments in the concrete space that are kind of compounded in a positive effect to now printing a home in concrete? Like, are you able to leverage off of some of those developments?
I think the biggest developments are probably the additives, the plasticizers, the air entrainments, and then the how quickly your concrete sets, right? So depending on the type of printing that you're doing, this particular home was printed with a gantry system, so it printed the entire house one layer at a time. So this house started on the ground floor, with one layer, and it ended with the final layer, and, every wall segment being printed at the same time. And we've actually invested in a printer that is a robotic printer, so it'll be printing segments. So we might take like a 9 or 10 foot wall section and print that from the bottom to the top. So now you think about the difference in the nature of the ink that you need to print that, because now where we were spread out over a much larger area, we need a slower curing concrete so that we get the bond between the layers.
You're running 20 linear feet of one layer versus 9 linear feet of a layer for a wall.
Yeah, and so then as you go up, that has to solidify much quicker to bear the weight of the the following layers. So those type of things are where really the technology advancements are helpful for 3D printing.
So where do you guys hope to end up price-wise? So obviously this one, there's a lot of R&D that has gone into this house, and it's taken a lot more time than maybe future renditions will. Where do you guys hope to be at a cost perspective to make this an affordable product for people?
So I just want to back up just a little bit and talk about sustainable concrete innovation maybe and our goal and desire, right?
Yeah.
So I've been a builder for 30 years. I do have a building company, currently here in Lima, and we build homes. We build custom homes. That's been my background, right? So design and build custom homes, taking, your dreams maybe of a lifetime and turning them into reality. And that's what I love to do. I love to take that, that desire, that thought, and used to be before your guys' time, everybody would come to me with a folder jammed full of pages of newspaper or house magazines that they'd torn out. I like this, and I like this, and I like this.
We call that Pinterest now.
Yeah, Pinterest and house, right? Like, so now everybody's like, I got this house, this house folder. I'm going to share this with you. And so that's how things have evolved on a design standpoint. But that's been my background, and that's what I've done. And at the same time now, seeing with sustainable concrete innovations, the thing that we're able to do, and we just said, we can build homes and we can sell homes, right? But how can we be the most effective in the marketplace? How can we take the things that we've learned and springboard them into making a difference in our community and in our state and in our region, right? How can we do that? And so our goal really with sustainable concrete innovations is not so much to be a complete home builder, but to be a printer. We want to really do a good job on printing, and we want to partner with other builders and developers to do that. So our goal, like looking forward, is to come alongside other builders who are like, hey, that's very interesting, but maybe I don't have $750,000 or $1 million to go out and spend on a printer. How do I do this, right? And so with the right printer, the right people that are trained, I can do with one printer, I should be able to achieve somewhere between 40 and 50 homes a year with one printer.
Wow. Right? And when you say come in and do a really good job at printing, you're talking about the foundation, the footer, the floor, the walls.
Correct. To some degree. Design, absolutely. Like without a doubt, we need to be involved in the design to make these successful. We have to do the design work. And then we need to, maybe a builder already has a really great concrete crew that's willing to be part of that. We're open to that. But then once that foundation, that slab is in, the underground utilities are placed, right? The water lines and all those type of things that are going underground, the drain lines are in place, then we're going to come in with a printer and we're going to print that home, and we're going to make that happen in a very short order. Then missed opportunity, as you said earlier. So now if you're taking, like right now, you're spending maybe 3 months building a home. With a really successful crew. I mean, a 3-month window that's a pretty short window for I would say like a quality home, right? Something you're maybe 4 to 5 months even, depending on how many guys and how well you've choreographed that. But now, once the foundation's in, cured, and we come in and we bring our printer in, 4 days later we're done. 5 days later we're done. We wait a week. We do the wall fill, the structural support. So 2 weeks after we got started, now you're ready to put a roof on it. So you can really, like I see easily within 4 to 6 weeks is a possibility for home completion.
No way.
Choreographed properly.
That is so crazy.
That's not starting out. Like we're going to be 2 to 3 months, because there's the learning curve that goes with that. But if somebody that's committed to this, that there's like, we're gonna get behind this, they're gonna benefit in the long term from it, because they're going to realize the value that the automation can provide for them. And so sustainable concrete innovations, we're developing some homes right now. We're doing some homes. We're proving the concept of affordable housing. But back to your question on price, I think that it's possible to be under $100 a square foot for a finished home. For the home cost, right? So you've got some utility costs involved in that, connections, lot prices, all of those kind of things. But $100 a square foot is very doable, and that depends on the level of finish, right? So how much you want to finish and how much you want to put in. Do you want vaulted ceilings like we've got here, and do you get the custom work, or do you want to really make this affordable? So my goal is 1,200 square foot homes. Hopefully in the next year we're going to have some 1,200 square foot homes, maybe a little bit smaller homes as well. On the market for in the neighborhood of 150 to 180.
Wow. Yeah, that would be
marketability.
That would be incredible.
You're talking about a new home.
I know.
You know, like Seth and I right now, from a real estate perspective, we're selling stick-built spec homes for $200, $205 a square foot.
Yeah.
And so to think about having a new product, brand new.
Yeah. Under 100, 150 or less.
I mean, that's
crazy.
Yeah, that's just going to be pretty incredible,
Do you know this
especially if you
question?
can do it at scale.
Can someone go get a construction loan? And like, if I were just like, hey, John, go build me a house for 100 and, 3D print me a house.
Yeah.
Could I go get a construction loan and a bank feel comfortable with that?
Yeah, actually you can. So we're in the process of doing two things right now. And I personally am actually going through the process of taking out a construction loan.
Oh, nice.
On a home. Because the next project that we're doing is on my property. We're going to be using that for both model home and office. Right. So I'm going through the process so far, no hiccups. And really the driver behind that is Fannie Mae, Freddie Mac came out with guidance at the end of 23 that said, look, a 3D printed home is built of conventional materials.
Yeah.
So a home built of conventional materials, you can appraise it against any other home built out of conventional. No special
assessment on the price.
Which now that I'm here, it would be ridiculous for like an appraiser to come in here and be like, this is like, this is worth less for some reason because it's concrete.
Because it's new.
It looks amazing in here. And I mean, it's just.
And to your point, concrete homes are not a new thing. This one may have been printed, but
and
that's
actually been an interesting. Just a little side note is that I've been building barn dominiums for the past probably 8 or 9 years. It's kind of a trendy thing and it's been less expensive, a less expensive way to build. But the financial end, on the financing side of it, like Fannie Mae and Freddie Mac, they won't back those. So any bank can't take and loan a 30-year loan on a unless they're willing to hold it. So they can't sell that back and securitize that, right? So that has been a huge holdup. So even from that respect, that hasn't stopped financing. There's still a lot of local banks around here that are financing. We're not having any trouble getting financing for those, but I see there being even less of a
That's
barrier.
so ironic because that's literally a stick-built structure, a barn dominium.
So I think the foundation is the big holdup there on that.
Huh.
Isn't
that just a slab?
It is, but the foundation is not continuous. So you have post foundation, right? And it's so Ohio here, right in this area where we're at right now, code enforcement is not even abysmal. It's non-existent. So we do have a building code in Ohio, and there's in the rural areas it's not enforced at all. Mm-hmm. And you have a lot of builders who are, and I've been involved in some lawsuits actually as a professional witness for guys who built barn dominiums and just did a horrible job. Just took advantage of the customer and not knowing what's and the building code applies. So the building code applies to this house as it does to any other house.
Yeah.
And so if you get into a litigation situation, the building code is the final say. Yeah, that's the final say. And so interestingly, probably for us on the design end of things, it's a little more difficult on the design and securing permitting because building code doesn't address 3D printing yet. It's not there. Right. Like they know it's coming, right? They've experienced it, they've seen it. But what the building code does have contained within the building code is a section which allows you to use commercial code in residential construction.
If there isn't residential code to
the code, because just in lieu of, right? So you can actually build say like a mass timber, like they're doing mass timber a lot in commercial now, in like even high rises and skyscrapers out of mass timber instead of steel and concrete. So you can engineer for that because there's known parameters, right? So concrete has known characteristics. So what we do is we take our plans, submit them to engineering for structural loading and those type of things, and then allows the engineers to certify those, stamp those, and we take those to the building department. It allows them a way to allow us to do this right now until the building code catches up.
What does the future of SCI look like? You had mentioned a little bit of your end goal of wanting to work with contractors. Somebody listening to this episode, what's the call? Like, where would they go to learn more about this? Who would this be applicable for?
Yeah, so we will build for owners, right? So if you came to me and said, John, I really want to build one of these houses, will you build the whole thing from the ground up? We're able to facilitate that here in the Lima area and the surrounding areas through the partnership of Sustainable Concrete Innovations and Open Vision Builders, which is my home building company. So we can facilitate that here locally.
Start to finish, design, build, solution.
Yeah, we could do that here, but that said, Open Vision Builders is busy too, right? So
Right.
we want to partner with other builders as well. So we don't want to. We're looking at this as a partnership with other builders to be successful. We want those in the community to be successful. Ultimately the community gains, we gain. The builders gain, and I think that is a win-win for everybody. But sustainable concrete, really, what we're looking to do is to build that model where we can go out and work with other builders. And so we're committed to putting on as many machines as necessary to make that happen. Our short goal is we want to have 5 machines in the first 5 years. So
wow,
that's subject to change, as demand needs. But you think about
you
that.
need to wait for a Black Friday sale to buy your next machine.
Definitely. Yeah, unfortunately, they capped the sales tax at $500, so we were just over that. So the sales tax holiday didn't account for 3D printers.
Didn't help. Yeah.
So we want to be printing for others. You can go to our website. Anybody could go to our website. It's Live 3D Homes, so LIVE 3D Homes.
We'll put that in the show notes.
live3dhomes.com. And through there you can reach out to one of us as partners. There's a contact form, so you can fill out a contact form and send that to us if you're interested in that. And we are looking for people to work with in 2025. So we're pretty, our pipeline for the short term here is pretty full with these concept homes that we're doing through the early part of 24. But after that, really the sky's the limit. They say, we're ready to dive into this. And part of this we haven't really talked about, mortar design, right? So designing your mortar for this area, for the aggregates that we have. We're right in the middle of that right now. So We've acquired a machine. We're in the process of getting training on that for the next project, and with that, comes the ink design. What are we going to use? How's our media going to work? How is that? So we're in the process of doing that as well. So lots of things on the learning side of things for us here at Sustainable Concrete Innovations.
And this home that we're in may potentially be open for an Airbnb type stay.
Yeah. We're planning on that really in pretty short order here. It's furnished, it's ready to go, and we've actually given away the first weekend if she wants to use it. I can't remember the gal's name now from Cowan Realtors. Won.
Shannon.
It could be.
Okay.
I don't.
She won
all I know
on the open house.
Is it wasn't my business card, and
it was not your business card. Yeah.
Not
So
bitter.
we drew. Yeah. So we drew. We had a door prize during our open house on the 18th of July that we had here, and then bring a business card, and we drew one, and I think it was Shannon. Yeah, she won the first weekend if she gets the timing, everything right. So.
Yeah. Well, John, thank you so much for the time, and it was cool for us to be able to come on site here, which I think will do a lot of justice. You need to get into one of these in order to really understand how innovative, how different, but how the vision is a lot bigger for the potential of this. And I'm excited to see where you guys go in the coming months in the next year. And thank you for your time.
And this is our first portable podcast that we've ever done.
Yeah.
So
it's
pretty
exciting.
It's a fitting place for it. I mean, it's been a really cool experience.
I would just like to reiterate that this is the first 3D concrete printed home in Ohio, which is wild to me that we're in Northwest Ohio outside of Wapakoneta.
Yeah.
And this is the first one.
Trust me, that goes through my mind like
That's crazy.
every time I pull in the
wild.
driveway. That the fact to be part of it, to be part of doing this, is really like never was in my bucket list, and absolutely has been a phenomenal experience, and we're super excited about what this is going to do in the next 5 to 10 years.
At the time of this recording, there is one in Columbus that they're in process with.
Yeah, they're just starting. They're having the same learning curve that we did. A lot of the same
They
issues
said
from what I've seen.
nothing good can come out of Nazareth. You know what
Yeah.
I mean? So, little old Wapak, Ohio. No, this is really cool. We'll put all of those links in our show notes, as always, if you're listening, to go check that out. Do you guys have a Facebook page?
We don't yet.
Don't
Yeah,
yet.
we don't
Okay.
yet,
so keep on the watch for that. And you were talking off camera that as you guys get into some of these next builds, you're going to try and capture some of that stuff and put it out there on the ether that is the internet.
Yeah, we're really looking forward to doing a live stream. Hopefully to get that set up and embedded in the website so that anybody goes to the website, they can
see it in action.
See
they
some
can
builds.
we'll have a contact form there where they can plug their email address in or their phone number to get a text, so we can shoot out some notices when we're going live and whatever, so that they can kind of get a little bit more feel for what we're doing. Yeah, and actually that's not just for the print process. We want to do that with the whole home, like the experience, right? So it's been a dream of mine for actually a long time, even in the custom home building, to do that, and I think it just fits so perfectly into what Sustainable Concrete Innovations is doing. So we're excited to bring that to the table.
Yeah. Awesome. Well, thank you so much for joining us today.
Yeah, thank you.
As always, excited that you joined us for another episode of the Reinvest Podcast. Stay tuned every Tuesday for new episodes. And if you want to learn how you can use your hard-earned capital to diversify into real estate, go to our website, lv5capital.com, and shoot us a message. Move farther, reach higher, and grow deeper. We'll see you next time.